Hey guys, it's Solbyte, and today I'm going to be going over destructors. They're a pretty important topic when it comes to object-oriented programming, especially in the use cases of when you would want to allocate memory on the heap, and maybe you'd want to do that for an object or whatever else. So yeah, let's go and get into it. So just like a constructor. So what do we know about a constructor? A constructor you can think of like the builder, so the class is the blueprint for creating an object. The constructor is the builder that actually builds the object and fills in certain members. Like for instance, it can fill in the value in for whatever object is created through the value class. And yeah, so let's go ahead and do that really quick, so that way we can kind of start from a constructor. So we'll do value, all right, and we will have pass in int num, okay, and then we're gonna go over here and just set in to num. There we go. And so now we have a constructor that whatever we pass in, whenever we actually create the object down here, we'll set whatever we pass in equal to the in member of this object. So that's great. Now a destructor is just so a builder, a constructor is like the builder. A destructor is the thing that destroys the object when it's no longer in scope or the program ends. So a destructor is automatically called when the program is ended. And so that's why I haven't really gone into it too much in the past, because it was kind of automated. But there are many use cases where you would need to explicitly define what your destructor does for whatever certain reason. So we're going to go ahead and create a destructor. So the way that we do this, it's a bit different from a constructor. And we will use this little squiggly mark, the tally, and go ahead and fill it in like a normal, or sorry, don't fill it in at all. My bad. Do not fill, yeah, so a destructor has no parameters. I was getting a little ahead of myself for later, but yeah, a destructor has no parameters. All right, it just simply does what it needs to, okay? So I'm actually gonna make the syntax a little bit more simple, so that way we can actually kind of explicitly see when the constructor is ran and when the destructor is ran, okay? So for the constructor, we'll just say constructor finished and then line. And what we will do is we will just see out the value of in. Okay, so there we go. Then I'm gonna do the same thing here. So destructor finished. All right. So this will tell us when the object has been deleted. Okay. So let's go down here and actually create an object of value. So we'll just call it number. Yeah, that'll be good. So, and then we will pass in 3. All right. So we don't have to write anything else down here, because these will automatically run whenever it constructs and when it destructs. So let's go and run it in the terminal really quick, so that way we can kind of get an idea for when these values are, or when the constructor is doing what it needs to do, and when the destructor is doing what it needs to do. All right, so let's go ahead and run this. And as we can see, I actually made an error. I never set in equal to anything. I forgot to do that, so let me actually go ahead and do that really quick. Sorry about that. So we'll set in equal to num. So now that should be good. Yeah, so we got just a random value, 686. But as we can see, the constructor did finish and the destructor finished. So both were called during the program's execution. We kind of explicitly called the constructor here using, the syntax, but we never had to explicitly call the destructor. So that's something kind of about destructors. There are some instances where you could kind of explicitly have it do something at a certain point, but for most cases, it will just automatically run whenever the object is or goes out of scope, or if the program ends. So like if we did have a program, or sorry, not a program, a function that an object was created inside of, whenever that function is done running, the object would be deleted by the destructor. So anyways, yeah, so that's, I mean, pretty basic. Destructors just kind of delete the object. And we can actually see this a little bit more explicitly whenever we do things like memory allocation. So we're going to kind of bring up an example of that right now. So we'll go back up here, and what we're going to do is we are actually going to make n be a pointer. Okay, so now n is a pointer. And now we can kind of, if you guys don't know much about memory allocation, I recommend kind of understanding it for object-oriented programming, or, I mean, you don't have to, but when it comes to destructors, that's kind of the most common use case for it, is by doing that. So anyways, what we're going to do is we're going to allocate memory on the heap. So we're going to write new, and int, and we are going to fill in num. So what this is doing is it is allocating a certain amount of memory on the heap for the integer for n. So perfect. I'm going to write a little line here that says that we allocated the memory. Perfect. And so if we do this, it's very, very crucial, all right, to free up the memory, right? As I'm sure many of you guys might know. So, and one more thing too, we need to dereference, and so that way we can actually see the number. So, because if we filled in 3 and then we didn't dereference it, we would just get back the memory address. Anyways, so now we just need to delete n. Okay, so I'm going to write delete n. All right, and then right here I'm just going to write memory released. So the memory has been released from the heap. So now we don't have to worry about any sort of memory overflow issues. So this is a very common use case for destructors and needing to explicitly define them. So now we're going to go down here and rerun the code, and we should get back basically the exact same thing. So we get constructor finished allocated memory. So the constructor allocated the right amount of memory and then printed the number that the n pointer is pointing to. And then after the program has ended, the destructor executed and freed up that memory. So we don't have to worry about any sort of problems caused by memory overflow. So, and yeah, that's about it. I'm going to leave some resources down in the description below for anyone who may want to kind of look a little bit more in depth about kind of what you can do with destructors and etc. But this is kind of basically it. I mean, it's a very simple topic, so it doesn't really need too long of a video to really go over. But yeah, very useful for memory allocation. So if your programs rely on something like that, then you know there's a good chance that if you're also utilizing object-oriented programming, you will need to be able to dive into destructors. All right, and that's about it. Feel free to leave any comments in the comments down below, any questions down in the comments down below, and thank you guys for watching.